Good morning. Today we are going to see the fifth day exercise problems. So we have first, that is a solid shaft has to transmit 75 kilowatt at 200 rpm, taking allowable shear stress at 70 Newton per mm square. Find suitable diameter for the shaft if the maximum torque transmitted at each revolution exceeds the mean torque by 30%. This question was asked, that is in 2019 for Indian Engineering Services, that is IES. And in simple, we know power. So knowing power, we can find T, and knowing T and shear stress, we can find diameter. So we have to use first formula. P is equal to 2 pi n T. We have RPM, so we have upon 60, and here we have T, that is T average. Then find T max. Here you will get value of T, that is in Newton meter. Convert it in Newton millimeter over here, and T max, that is equal to 1.3 into T average. And knowing this T, we can use T by J is equal to tau by R. Solid shaft is given, a solid shaft. So you can have this in this fashion also, because J we have pi by 32 d to the power 4, and R we have d by 2. So we can cancel 2 with this 16. D will give d cube, and you can use directly formula for solid shaft. T is equal to pi by 16 d cube into tau. And from this we can write T cube, that is equal to 16T upon pi into tau. And from this D will be cube root of 16T upon pi tau. And that will give you value of T. Then we have another problem. A solid shaft 200 mm diameter has the same cross-sectional area as that of hollow shaft of the same material with external diameter as 250. So area of solid shaft is equal to area of hollow shaft. And this is pi by 4 into 200 square. Whereas hollow shaft we will have pi by 4 into 250 square minus d square. And from that we can find the value of D. And then we have to find the ratio of power transmitted and angle of twist. So we have to find T for solid shaft and T for hollow shaft. So T for solid shaft we can have, just we have seen, pi by 16 d cube into tau. And for hollow shaft, we will have this as pi by 16 into d4 minus d4 into tau upon d. Because this is not cancelled, because for hollow shaft, we have J pi by 16, pi by 32, d4 minus d4, and R we have d by 2. So this 2 gets cancelled. So pi by 16 will be there for d4 minus d4, and this d will remain as it is. So from this we can find T, and knowing T, we can find power for solid shaft and power for hollow shaft. Now actually if we will see this remaining part, so we have 2 pi n T solid average and 2 pi n T hollow average. Now in this, we have this 2 pi n same for this. So power of solid shaft upon power of hollow shaft, if n is same, is nothing but T of solid shaft upon T of hollow shaft. And then you have to find angle of twist. So we have T by J is equal to G theta by L. And from this we will get, therefore, theta this is equal to TL upon Gj. And we have to find it for solid and we have to find it for hollow. L is same, G is same, that will be cancelled. And then you have T solid upon J and T hollow upon J. Likewise, we have to find it. So now we have this is second problem. Now go to the third problem. A composite shaft of copper rod 50 millimeter enclosed in a steel tube of 60 mm external diameter and 5 mm thickness. So rod we have 50 millimeter. So we have this will be rod. And then over this we have 5 mm thickness. So exactly internal diameter becomes 50. So we have a external diameter 60. And internal diameter is same that of solid shaft. So this will be 50. Determine shear stresses developed in copper and steel rod if both the shafts have equal length. L is same. Shear modulus for copper and steel is given. So this is GPA. Respectively, torque applied is 1400. So we have these shafts enclosed, a composite shaft. If you remember unit number 1, we have this composite and there we are going to use that is compatibility equation. That compatibility equation there we are using deformation is same. Solid that is equal to delta hollow, if you remember. In this, we are in the same fashion. We have deformation is theta here. So theta s that is equal to theta hollow. And just we have seen this formula for theta, TL upon Gj. And that we have to put here, TL upon Gj. This is for solid. And TL upon Gj, which is for hollow. L we have same, so gets cancelled. And then we have to put the values, and from which we will get relation between TS and some constant TH. And then we know TS plus TH, we have given 1400. And by using these two equations, we can find value of TS, we can find value of TH. And then by using T by J is equal to tau by R, we can find this for solid. And similarly, we can find this for hollow. So likewise, we have to solve these problems for torsion. So now we will stop here only. The remaining part we will see in the next lecture. Thank you.